Welcome to the video for lesson 8.6, the Pythagorean theorem. So now that we've looked at area of different quadrilaterals and triangles, what we'll be building into is one of the most common theorems that is used throughout mathematics, which is the Pythagorean theorem. And this is a theorem that can be proved using the area postulate. So again, the idea of area is what allows mathematicians to use Pythagoras' theorem. So simply put, what you want to keep in mind is the Pythagorean theorem only relates to right triangles. So in any right triangle with legs the length of A and B and hypotenuse the length of C, then a squared plus b squared equals c squared. But the key is to realize that a and b are the legs of the triangle, so the two sides that meet at the 90-degree angle, and c is always the hypotenuse, which is the longest side that's opposite the 90-degree angle. Now, the proof that builds into where this comes from is based on this image over here to the right. I'm not going to worry about going through each part of that proof and where the idea of Pythagoras' theorem came from based on the area postulate, but I will include an additional video for those of you that are curious to take a look at. But it can basically be summarized into this one image. So applying Pythagorean theorem. So example 1, length of a soccer field must be between 100 and 130 yards. The width must be between 50 and 100 yards. What is the range of the diagonal of the field? So in order to find the range, we want to do the diagonal of the smallest possible field and the largest. So the smallest field is 100 by 50 rectangle. So in that case, our legs, if we draw the diagonal in there, would be 150 for our right triangle. So using Pythagorean theorem, 50 squared plus 100 squared would equal c squared, the measure of that diagonal. So 12,500 equals c squared, square root to get what c is, and c is approximately 111.8 yards. Then for the largest field, we have a 100 by 130 rectangle. So our legs would be 130 and 100. The diagonal is the hypotenuse. So 100 squared plus 130 squared equals c squared. So 26,900 equals c squared. Square root both sides. Square root of 26,900 is c, which is approximately 164 yards. So our diagonal range would be from 111.8 yards to 164 yards. So again, the key to Pythagoras' theorem, though, is making sure you know the hypotenuse is always the letter C. Legs are always A and B. Now moving into Pythagorean theorem's converse, or the converse theorem, which states, if we have a triangle with side lengths A, B, and C, if a squared plus b squared equals c squared, then we know that triangle is a right triangle. So for example, if you were told you had a triangle with sides of 3, 4, and 5, you would want to check, does a squared plus b squared equal c squared? And to know what c is, it would always be your longest side. So does 3 squared plus 4 squared equal 5 squared? Both are 25, so that tells us we would have a right triangle. Now, the other thing to keep in mind, if this does not come out to be a right triangle, if we end up with c squared being greater than a squared plus b squared, we know it's an obtuse triangle. If c squared is less than a squared plus b squared, then we know it is an acute triangle. So example 2 is looking at that converse. We know the triangle has side lengths 7 centimeters, 8.2, and 10.8. Is it a right triangle? So is 7 squared plus 8.2 squared equal to 10.8 squared? Well, if we do the math, 49 plus 67.24 is 116.24. 10.8 squared is 116.64. So in this case, they're not equal. So it is not a right triangle, but instead a squared plus b squared is less than c squared. So we would know it is an obtuse triangle. Then we get to our final idea for today's lesson, which is the idea of Pythagorean triples. And a Pythagorean triple is a set of 3 whole numbers that can be the lengths of the sides of a right triangle. So like we looked up here, 3, 4, 5 makes a right triangle. So 3, 4, 5 is a Pythagorean triple. Another common Pythagorean triple is 5, 12, 13. Now, there are infinite amounts of these. So what I did is I included a handout to go with your notes with a chart that has some of the most common Pythagorean triples on it for you. But in example 3, we're going to see how we can determine if a pair of 3 numbers is a Pythagorean triple. So in this case, we have a set that's 7, 22, and 28. So we're checking, does 7 squared plus 22 squared equal 28 squared? 49 plus 484 is 533. 28 squared is 784. So in this case, c squared is greater than a squared plus b squared. So it would not be a Pythagorean triple. And we know this triangle is obtuse. So going back to the real basics, though, we need to keep in mind Pythagorean theorem comes from that area postulate related to the area of rectangles and squares. And then the idea that Pythagoras' theorem is a squared plus b squared equals c squared, where a and b are the legs and c is always the hypotenuse.